Welcome everyone to this new episode of the Privacy Rules Privacy Espresso series. Here is Alessandro Di Mattia, Legal and Executive Officer at Privacy Rules. And today I'm joined by a guest speaker coming from Vienna, that is Tomislav Rachev from the team of Jentis, that is an IT company based in Vienna, of course, that provides server-side tracking solution. And as a legal counsel today, we will speak with Tomislav about an interesting topic that is the one of differential privacy, that is something they are working on directly, let's say, or that they have a direct knowledge about. We will discover why soon. So without further delay, I would like to leave the floor to Tomislav, thanking him for being with us, of course, and asking him, what's differential privacy, what we are talking about today.
Great, thank you, Alessandro. Let's start with the basics. Well, differential privacy, it is in essence a privacy-enhancing randomization technique, which can help companies avoid re-identification of individuals while still allowing them to get valuable insights from their data. So how it works technically, companies add random data points, or so-called noise, to the output of the results of queries made on a data set. So this might sound very technical, very complex. So let me illustrate this with a simple example. Let us imagine that a survey is conducted with only one question. How often do you eat chocolate per week? Now, if a person is a major chocolate lover and eats chocolate, say, more than 10 times per week, he might not want to reveal this, or even might have second thoughts about participating in the survey. So what if there is a mechanism that ensures that every fifth answer in the survey is not real? It is randomly generated. It is added randomly by an algorithm to the dataset. So in the case of a data leak, for example, a hacker would not be able to attribute this answer to this person with certainty, because this person would have reasonable deniability that this answer is actually his or hers and not randomly generated by the algorithm. So this person might be more inclined than to participate in the survey. And of course, the survey might not refer to chocolate consumption. It might refer to a medical condition, which is even more sensitive. So of course, in such cases, this privacy-enhancing measure comes in handy. Of course, this example is a major simplification, but in essence, it grasps certain principles of differential privacy that are true. This differentially private algorithms that I used, they ensure that the statistical output on, in this case, chocolate consumption patterns among the survey participants does not allow, this statistical output does not allow inference on individual responses. And still with a large enough sample, the survey would give meaningful statistics. So in a way, differential privacy paradoxically allows you to learn nothing about an individual while learning useful information at the same time about a group of people, be it chocolate enthusiasts, a population of a city, or a group of patients.
Perfect. Thanks a lot for this very quick and brief but clear explanation. It's easily understandable how relevant differential privacy can be under the security perspective, of course, but also under the compliance perspective. And I understand that these may be extremely useful for what concerns, as you were saying, data analysis. So my next question would be related to data analysis in particular. Which are the main benefits and the main challenges in using differential privacy for data analysis?
Sure. Well, the benefits consist mainly that it is quantifiable. It is a mathematical framework that provides a safeguard against the identification of individuals in a data set, even if a third party such as a data analyst or a hacker has some additional information about the individual. And this framework is based on the concept of a privacy budget, typically denoted by the letter epsilon. So this privacy parameter, it measures the privacy which is lost by the individual. So the more random data you add to the dataset, the more noise you add, the lower the epsilon, and the higher the privacy of the individual. So the challenge in this context is, of course, that the more noise you add to the data set, the less precise the outcome becomes. So a data controller must be able to design a differentially private algorithm and define how much noise needs to be added and for which data points in the data set to get the necessary privacy guarantees, but also to keep the data set usable, to retain data utility. So another challenge is, of course, the assessment of the risk for re-identification. It's important to continuously monitor these algorithms to assess the possibility for re-identification, taking into account all the means likely reasonably to be used to identify a person. This is under the applicable case law of the European Court of Justice. So as long as the original data remains, the data controller is able to identify individuals in the statistical output. So the retrieved data would likely be considered pseudonymous and not anonymous, and GDPR would apply to the data controller. So it is really important to understand the scope of the data processing on one side, and to what extent the randomization functions should be applied to this data set.
That's incredibly interesting, and we immediately understand the implications of using this type of tool. But what about the application of it? So, what are current examples of application of differential privacy, so that we also understand in practice, what we are talking about?
So I could only speak, of course, from the perspective of a technological company such as Jentis. But to me, I think it is important to differentiate between dynamic context on one side and the static context of data handling on the other side. So what do I mean by dynamic context? This is when a company allows its data analysts or a third party to retrieve on a continuous basis data from its database, from its raw data. So in such a context, yes, there are clear benefits of differential privacy because it allows to apply this algorithm to the retrieved data and ensure that based on this retrieved data, the third party it cannot really infer and make conclusions about the individuals involved behind the data. So to give you some examples of current applications, when we look at the industry, at the public sector, there are some government agencies that publish, for example, the demographic information or other statistical aggregates about the population of a city, of a country, while still ensuring the confidentiality of the survey responses, exactly by applying these kind of techniques. But not only public bodies, as well as private companies, even big tech such as Apple, for example, uses such algorithms. There is a variation of differential privacy called local differential privacy, which is local because it happens on the device of the user. And these algorithms, they randomize certain data points in the data set on the user device before feeding this data into Apple's machine learning models to learn about the kinds of photos, for example, that people take as frequently visited locations. These kind of machine learning models based on differentially private algorithms, they are used to show memorable pictures and locations to users of the Photos app of the iPhone, for example. So this is definitely some examples from the dynamic context of data handling. But what about the static context when you just send the whole data set to the third party once, and you expect, for example, a statistical analysis from this third party? To give you some context about this, a website operator collects the data of its website visitors and sends it to third-party providers such as Google Analytics, such as Meta with its Meta Pixel. So the website operator sends all of this event data, it's called, or usage data of the website visitors to the third-party provider and expect an analytics report in return. So in such a context, it's, from my perspective, does not really make sense to apply such sophisticated randomization function such as differential privacy, because it really takes effort, time, and cost to design it in a way that really adds exactly sufficient noise to the data set, and also defines the clear data points that must be randomized. So it makes more sense to randomize the original data of the website visitors, to select certain data points, being in control of the data collected on the website, select certain data points, replace them with certain random values, and then send this data sets to the third-party analytics providers. So by selecting these quasi-identifiers, replacing them with random values, and only then sending the data to the third party, companies are actually able to pseudonymize the data in Europe before sending it abroad to the US and other third countries. So this randomization technique, it strives to achieve a so-called K-Anonymity, which is basically making the data not linkable to a few amount of individuals, so that for the third party, it is possible to trace back the sent data to a specific website visitor. So this is something that I can give as a first-hand example, because Jentis, our solution, provides such a functionality of randomization, of applying pseudonymization functions, anonymization functions on all kinds of data points that are collected on websites, such as IP address, metadata about the user device, and third-party identifiers. So by giving this control over the data that is collected on websites, giving the control to the website operators, then Jentis enables this website operators to really take back control and decide what data to send to these third-party providers, and still being able to get statistical reports and meaningful analytics in return. So to sum up, it really depends on what kind of context you're handling as a company, what kind of context your data is processed within, and based on that, companies can decide what randomization technique makes most sense for them, whether to go for differential privacy or aim for the briefly mentioned K-Anonymity instead.
That's perfect, Tomislav. Thanks a lot. And it's very clear also the distinction between K-Anonymity and differential privacy. This last one cannot always be probably the best solution for certain cases and for certain companies, as we have heard from you. So that was very good to know, also because it's good to know that there are companies like Jentis that are providing those solutions that would, of course, enhance not only the company's security, but also their compliance, because as you rightly say, those solutions are supportive of the so-called pseudonymization and anonymization of data. Tomislav, thanks a lot for being with us today. I would also like to thank the entire Jentis team and our listeners and followers for being with us. And I really look forward to meeting you at the next Privacy Rules Privacy Espresso, but also at our event in Brussels next week. So 13 and 14 of November, we will be there, and everyone is invited to join us at our public event on the 14th. So check our website for that and see if you can join us. You will definitely have the opportunity to meet me and Tomislav. It was great. So looking forward to meeting you all, and have a nice day in the meantime. Bye everyone, and bye Tomislav again.
Thank you. Thank you.